y, and this coming out is z. So all these three things are perpendicular with each other, right? These are all perpendicular. And if you look at the corner of your room, so your corner of your room will look like, and this is the corner of your room. One is going in this way, this is the height, this is the floor, this is the floor that you have. So these three things are perpendicular to each other, right? This is how your corner of this looks like, right?
Yes, sir.
Okay, so now what was I asking that what is the angle between I and J? What is the angle? So you have already good. So that is 90, right? Sine of 90. So sine 90 is 1, this is 1. So this would be K. So I cross J would be K hat. Okay. Now, similarly, one. Okay, so similarly, you tell me that what would be J cross I? How much would be that? Think about this. Take your time and tell me how much would be J cross I. Please think about this. You know that what is A cross B? A cross B is AB sine theta n hat. You get the direction, you get this AB sine theta, and tell me how much. Please think about this and tell me in 2 minutes. And if you face any difficulty, then you will just right.
Yes, sir.
Please think about it.
So like I cross J is and J cross I will also be K, right? But like as you said, might be in like the negative direction. So
Yeah. So you are thinking absolutely in the correct way. But if we apply this thing, right? So if you put right, think it like this. How do you get this thing? So magnitude part would be how much? Magnitude part would be magnitude of J, magnitude of I, sine of theta. N hat we want to find out. Sine theta is 90, so all these things are how much? Magnitude of J is
magnitude
magnitude
of
J hat is how much?
90,
Magnitude of J vector. J is unit vector. Magnitude of J.
magnitude of J vector. Hmm.
Magnitude of J vector. Yes.
Yes, sir.
How much would be magnitude? We have just talked about this. These are unit vectors, all right. So what is the magnitude of unit vectors? That we have discussed so many times. Please revise. Okay. What is the
Yes.
magnitude? What is the magnitude of J hat?
So the magnitude of J is which let me try to think.
So think it this. What do you say is the J hat? What is J hat?
So their magnitude will,
Yeah, magnitude of J hat.
sir, I mean, it's not zero because it has some value, right?
Yeah,
So,
so it's cannot. Right? If it is zero, then it would be zero.
yes, sir. So, I mean, then again, it's not like some specific number is assigned to them. So, like, probably one or something, but I'm not sure.
Okay. So the meaning of J hat is that if you move one unit in a y direction, so how much you have moved in one, how much you have moved in y direction? 1 unit, right? So 1 unit, which means that magnitude is 1. And this only represents the direction, right? J hat, I hat, K hat, they don't have, so they only represent the direction in X, Y, Z direction, and their magnitude is 1, right? So by combining all those, let's say if you move X 1 unit in X direction, so that is I hat. If you move 2 unit, so that would be 2I hat. If you move 3 units, so that would be 3I hat. So by combining all these unit vectors, you assign the X direction, right? But if you move the smallest amount, so that is the I hat, right? 1 unit in X direction. So magnitude is how much? 1. I, J, and K, all these have 1 magnitude because they are all unit vectors, and unit vectors have magnitude 1, right? That was the definition of unit vectors, right? Yes, so their magnitude is
Yes, sir.
right. So magnitude of J is 1, magnitude of I is 1, sine 90 is 1, and we have to find out what would be the direction. So what was the idea that I have to apply? This is X I hat, this is J hat. So we are calculating J cross I. So we will put our palm keeping the direction of the fingertips in the Y direction, in the J direction, right? So how will we put our palm and our fingertips in J direction? What would be that? This is my palm, fingertips in J direction, but
Hmm.
my palm should face X direction, right? So let me in this. So
Yes, sir.
this is my palm in the J direction, right? And my fingertips in the J direction, my palm in the X direction. And if I curl my finger, so what is the direction that I am getting? What is the if I curl my finger, what is the direction that I am getting?
Sir, K direction,
No,
the
no, no.
thumbs.
Thumb is pointing into the screen. This is
Hmm.
going inwards in the screen, right?
Yes, sir.
For my side it is going inwards, but when you look at the video, so this is coming out to be outwards, right? But you try, right? You try to take your two pins and then put your palm in J direction and curl your finger in X direction. So what is the direction that you are getting? Please tell me. Inwards or outward? For me, this is outward. This is coming outward. This is going inwards,
So
right?
inwards, sir.
Yeah. So you are getting inward, right?
Yes, sir.
So inward is minus KF, right?
Yes, sir.
Outward is J, inward is minus K. Good. So this is very important because this thing will come across so many times, right? So we'll get minus K. So J cross I would be minus K. Good. Now you tell me that what would be I cross I. Please find out and tell me what would be I cross I. Use this idea. Use this idea and tell me. Don't bother about whether it is wrong or right. Don't bother about that. Please tell me, apply these scenarios and tell me what would be I cross
Hmm. So I into I.
I into I would be magnitude of I, sine angle between I and n hat. So that would be I cross I. That is the definition of cross product, right? So how much would be that? Whatever answer is coming into your mind, and obviously, if that is correct, then it is good, and if this that is incorrect, then I will tell you the answer, right? So don't bother about things.
So I'm just gonna guess and say J.
J. Hmm, okay.
Yes, sir. Not sure.
So how you will get I cross okay. So first thing, magnitude of I, magnitude of I. What is the angle between I and I
Zero.
0, right? So this is 1 into 1 and sine 0. So how much is sine 0
Sine zero is 1.
and sine 90?
Sine
Oh,
90 is
Mir, you have just joined. So you are very late. 46. Yeah. So sine 0 is how much? Sine 90 is how much? So we have done.
sine 90 is which is sine 90 is 1 and
Yeah.
sine zero is not it's zero. Zero.
Sine 0 is 0, right? So that is how the sine 0 is 0. So I cross I would be 0. Then this is 0, right? 0 doesn't have any direction, right? So Mir, we are discussing this cross product. So we have just started and we are just understanding this cross product, right? And we are trying to figure out what would be I cross J, J cross I cross K, and all these things. We are trying to figure out that. So yes, so I cross I would be 0. Now you both tell me that what would be I cross A, and then I will write the final result. So then I will write a small trick to remember this thing. You guys tell me that what would be I cross A. So I cross A would be I magnitude, K magnitude, sine of angle between I and K and N hat. So I hat magnitude is how much? What is the magnitude of I hat, please? What is the magnitude of I hat? Yes, Arsalan, what is the magnitude of I hat?
Sir 1.
1, right? So these are unit vectors. I, J, and K are unit vectors, so magnitude is 1. And what is the angle between I and K hat? I hat and K hat.
So 90.
90, right? So this is the sine of 90. And now we have to figure out this thing. Now sine 90 is 1, right? Now
Yes, sir.
n
Yes,
hat
sir.
is
Yes.
okay. So we have to figure out what would be. So this is our right. I hat. This is J hat, and for my side, this is a K hat, right? So this is a K hat, and I am trying to calculate what is. So this was my this was my X, right? This is my K hat. So if I put my palm in this side, right, in the direction of this side, right? So this is my palm. So this is my palm. How do I do that? So this is my K hat, and this is my X hat, right? I hat. So I put my palm in the direction of I. and I curl my finger in the direction of this in the direction of this k hat. So what is the direction that I am getting? What is the direction that I am getting? If I put my palm in the direction of I hat and then I curl my finger in the direction of k hat, what is the direction that I am getting?
Sir, minus J.
Minus j. Yes. So, me, did you understand that? Why did we get? How did we get minus j? Me, did you understand that?
No, sir.
No. Okay. So we get the cross product, right? So we get the direction of cross product. What did I tell you in the earlier class? That if we put our palm right in the direction of A hat and fingertips is in the direction of this A. And when we curl our finger in the direction of B hat, so whatever the direction our thumb points out, that is the direction of the A cross B. Right? This you right, Mir?
Yes, sir.
So now we have these IJK directions, right? So we have these IJK direction, and what I have told you that this is X direction. I hat, this is Y direction going upward J hat, and this is which is coming out of the screen. So this is coming out of the screen. That is my Z or K hat. I have these three directions, right? All these three are perpendicular to each other, right? All these three things are perpendicular to each other. And if I, so I want to calculate I cross K. So understanding this I cross J is very easy, right? This is I, this is J. So if I put my fingertips in the I direction, my palm in the direction of this J hat, and if I curl my finger, so what is the direction that I will get? Outwards. So if I calculate I cross J, I will get a K hat, right, coming out of this. So that is how I will get I cross J. Now I want to get I cross K. So I is this direction, right? And K is coming outwards. So I will put my fingertips in this direction, but my palm in this direction, right? So my palm in this, how do I write like that? So this direction, right? So this is the direction of I hat, and my palm is going outwards. And if I curl my finger, so I'm getting the downward direction, right? Downward, upward is what direction? Upward is J hat, so downward would be what direction? Yes, downward would be minus J. So did you understand this part? My finger,
Yes, sir.
yeah, my fingertips in the direction of I hat. You see my palm. My palm is in the direction of outward, right? You are seeing this portion of my hand. This portion is showing outward, right? My palm in the outward direction. And if I curl my finger, so I will get a downward direction. So I cross the K would give me, so I cross K would give me minus G at direction. Okay, so this would be how much? This would be minus G. And there is a simple trick to learn all these things. We can always go to the basics that how do we get the direction, but there is a simple trick that that we use to get all these I cross J and J cross K. So we use the cyclic property, right? And what is the cyclic property? And you guys, please always remember this, right? Because this is very crucial, right? So we write I, J, K in the cyclic manner, right? And we go in the cyclic direction. So this is clockwise, right? Is that clear? So if we go clockwise, if we calculate I cross J, so we will get K here, right? So clockwise, we will get positive. So I cross J would be K hat. K cross I would be how much? K cross I would be how much? We are going clockwise, guys. K cross I is how much? Yes, Arslan and me. K cross I, how much?
K cross I will be positive K.
K cross I, and then what is the arrow pointing out? I cross J, we got K. I cross J, we got K. So K cross I would be what?
Yes, sir, J.
J. Oh, I thought you said that K.
No, no, sir, I
And
said J only.
yeah. So and J cross K would be how much?
I.
I. Right. So these are the useful results. And we already know that I cross I, J cross J, and K cross K would be how much? All these things would be right. And similarly, if we go anti-clockwise, anti-clockwise is negative. So if we calculate I cross K, right? I cross K, so that would be minus J that you have seen it from this example. Similarly, if we calculate K cross J, so that is minus I. If we calculate J cross I, so that is minus. This is all the things that we will need to learn about the cross product, right? So, and where does this cross product come? So this comes in the electric charges and fields. This also comes in the magnetic fields, and this this also comes in the rotational motion. So angular momentum, angular momentum, and yeah. So all these things have this cross product, right? Torque, angular momentum, all these things are the cross product. Okay, so you guys please note it down, and then we will do one question, and then you will be able to understand it. Here. So please note down this thing, and if you have any doubts, please ask. Right? Please ask me if you have doubts. Otherwise, please note down. Right? Whenever you guys want me to scroll down, please. Just whenever you guys want me to scroll down, please,
Let's just scroll down.
yeah, and Mir and Arsalan, please don't hesitate to ask any question because this thing is very quick, right? So I is X is I hat, this is J hat, and this is K. So these are perfectly correct. and we can always look at our rooms in the corner, and when we see these things, so these will represent IJ and like, so do you guys have mathematics in your mathematics as a subject? You guys have mathematics? Yes, you guys have mathematics.
Yes, sir.
You have
Yes, sir.
okay, then I can talk about determinant, right? Then I can talk about it. Whenever you guys have moving it down, please and then yes, whenever you guys have noted it down and you want me to scroll down,
Yes, sir. Scroll down.
whenever you guys have completed these, because we have to put the torque on a dipole, and that we have to call, we have to recall off the question. Right? This thing we have done already in your 7th standard. I have to record. Whenever you guys have completed, right, start revising, right? Start revising. Don't leave it to the end.
Yes, sir, done.
Now let us do some question and then we'll be able to understand that how do we calculate the cost, right? So let's say that we have a vector which is I plus 2j plus 5k. We have a b vector which is 2I plus 2j plus 2k. And now we want to find out a cross. So one method is simply using the I cross j, right? One method is 2j plus 5k cross 2I plus 2j plus 2k. And we already know that which one will not survive. This term, and this term. These three terms will not survive. They will contribute to zero, right? So this would be 3I cross 2I. This would be 3I cross 3j. This would be 3I cross 2k plus 2j cross 2I and then 2j cross 3j and 2j cross 2k plus 5k cross 2I plus 5k cross 3j plus 5k cross 5. So which are the terms which will not survive? This one, this one, this one. These will contribute to zero. I cross I. Right, guys? And we have this cyclic property, right? So I cross j would be k, and I cross k would be minus of j, right? And then we have, I have cancelled this. This is I, right? So this j we cancel. So j cross I is minus k. So this is minus k. And then we have what? J cross k. So j cross k is I hat, right? And then we have k cross I. K cross I is j hat. And lastly, what we have? K cross j. So k cross j is minus I, right? These would be the things, and we have 8i minus 15i. So we have minus 7i, and then we have minus 6j plus 10j. So we have 4j, 9k minus 4k, so 5k. So this would be A cross B, right? This is one idea, but we have another simplest method, which is the determinant method, in which we can do the calculation very easily. We can calculate, and what is the idea that A cross B is just the determinant of I, J, and K hat, and AX, AY, AZ, BX, BY. So this is A cross. Right. Now using this idea, what is A? A was 3i plus 2j plus 5k, and B was how much? B was 2i plus 3j plus 2k. So if we use this thing, so AX is 3, AY is 2, AZ is 5. So A cross B would be how much? This would be I, J, K, and 3, 2, 5, 2, 3, 2. So how do we calculate the determinant? If we take I hat, so this would be this and this. So 2 into 2 minus 3 into 5. That is this, and minus j. If we take this thing, so this would be how much? This cancels, this cancels. So 3 into 2, right? 3 into 2 minus 5 into plus k hat. And I'm guessing that you guys already know the determinant, right?
Hmm.
This
Sir,
cancels, yes.
I'll be going to the washroom. I'll come back in 5 minutes. Okay, so
Okay,
I'm
yeah.
telling you because if you ask me something, I might not be there.
Oh, yeah, yeah, okay. Cool.
I'll come back
Yeah,
in 5 minutes.
yeah. Please return and minus j6 minus 10 and j9 minus 12. This is minus 11i. This is minus 4 plus 4, so 4j, and plus 5k. So this would be A cross B. I guess we have done something wrong with minus 11i plus 4j plus 5. These two are matching, and what did we do wrong with this? Let's suppose 3, 3, 9. Oh, this one. So minus, yeah, where is 5? This is K, and J, where is K? So this is 2 to the 4. So this is so from both these things, we will get the same result, but this is simpler and more hassle, right? So both these two methods are we can use. We'll get the same result from both these things, but this one is very easy to use, determinant method, right? So whenever we are given these things and we want to calculate the cross product, so we use the determinant. We can also use this method also, but this will take some time and we can do some calculation. right? But this one is easy. So, me, did you understand both of these parts? Yes. Are
Yes,
these,
sir.
yeah. So, if these are clear, then please note it down. And don't hesitate to ask me any question, okay? So, if you have any doubt, please ask. This is how we calculate the cross product of two vectors, right? Which are given in the Cartesian. So please note it down, and whenever Arsalan returns, then we will talk about the other topic. Yes, Arsalan, did you return? Yeah, so whenever you guys have noted it down, right? Whenever Arsalan returns, yes, Arsalan, have you returned? Yes, yes, no, yes. Yes, me. In the meanwhile, you please. Then you can ask any question if you have any doubt. Yes. Okay. Yes, Salam. Have you returned?
Yes, sir, I'm back.
Yeah, yeah. Back. Please note it down. We have already noted it down. We just discussed two methods. Calculate the cross product when we are given these Cartesian form of vectors, right? These are Cartesian form of vectors we already know. Whenever we are given these kind of vectors, so we calculate the vector product in these. One is determinant and the other one is I plus J. So quickly put it down and then we will talk about the important topic which is related to torque in a die. So that is important. And after that only electric flux will be revealed. So then this chapter will be over and I will quickly try to complete potential, then current. We have so many chapters: potential, current, and magnetic. Basically, look it down and we have yes, noted also.
Yes, sir.
Yeah, so we saw that this is much of a hassle, right? So using the determinant method, we quickly got quickly note it down and we'll get the same result, right? This one and get the same result, but with less hassle. We'll note it down and then dot. You guys have completed putting it down, please. Guys, please revise this chapter. This chapter, first, second, third, fourth, fifth, sixth. All these are very crucial chapters. Right? Revise those chapters.
Yes, sir. Done.
Okay, so now before we start on a dipole, we have to talk about this thing that you have done in your 11th standard. So, right, this is a form of a torque, and what is this? So let's say you have this rod, right? And you are applying an equal amount of force in this direction and in this direction, right? Equal amount of force. So what will happen to this? What will happen to this rod, right? So let's say I have this rod and I'm applying an equal amount of force in this direction and equal amount of force downward. So this will what? This will rotate, right? This will rotate. If I put equal amount of force in this direction, equal amount of force, so it will rotate, right, guys?
Yes,
Right?
sir.
And will it move in the upward direction or downward direction? So it will only rotate. It will not move upward. So it will not go like it will not go like right. It will not go like because I'm applying an equal amount of force in upward direction, equal amount of force in downward direction. So this will only rotate because it has a translation equilibrium, right? The downward force and upward force are cancelling each other, right? So downward force, this is pulling it upward, this is pulling it downward. So we have translation equilibrium, right? So they will not move in this direction or in this direction, right? Whenever the two forces are applied and they are in equal amount, so whatever force is larger in that direction, the object is effective, right? So let's say let's say I have this pin and I apply this force larger. So this will move in this direction and this will not move in this direction. So this would be larger. So it will go in this direction, right? So it doesn't have translation equilibrium, right? So it will, but this thing has equal amount of force in upward direction, equal amount of force in downward direction. So it will not move upward or downward, it will only rotate, right? So it will rotate in this direction. And that kind of torque is called a couple, right? When two forces are acted in opposite direction with a non-zero rotational equilibrium, right? So this torque is called, this torque is called couple. So two forces, equal amount, acting in opposite direction, right? And these lines, so these lines are called, so this is the line of force and this is the line. So these lines are called line of action. Line of action. And this couple is a torque. So torque is defined as the perpendicular distance between this line of action. So D, it is a perpendicular distance between line of action, and F is the right. So torque would be how much? This is perpendicular distance into the force, right? So this is CF or F. It's written like F. So this would be the couple or torque. Is this part clear, guys? Is this part clear? Is this thing clear, guys?
Yes, sir.
Okay. So similar thing happens when we put a dipole in a uniform external electric field. Torque on a dipole in a uniform electric or external electric. We have uniform, which means that parallel electric fields, and we are putting a dipole. So let's say this is the dipole that we are putting. This is minus q, and this is plus q. Right? So dipole moment is in this direction. Right? And can you guys? So this is charge plus q, and this is electric field. So what would be the force at this point? At this charge, what would be the force? Upward, downward, right hand side, left hand side. We already know the force on a charged particle in external. So what would be the direction of force? Yes, guys, what would be the direction of force? Upward, downward, right hand side, left hand side. Yeah, but what you guys, I will request you guys, whenever we meet in the next class on Wednesday, so you guys please look at force on a charge particle in external electric. This we have done already, right? And this is positive charge electric field in this direction. So force would be where? Extensively we have talked about this thing. So positive charge, right? Put in some external electric field. Force would be in the direction of electric field QE. That was the force. For negative charge, that was against the direction. Right? You guys remember this?
Yes, sir.
Yeah, so please revise. Otherwise, you guys will forget. Please revise. So, as I was saying, that for this one, we will have a force in this direction, right? And that is QE, right? That is QE. For this one, this would be in the opposite direction. So this is again QE. Both the forces are equal. One is this way and the other is this way. So are these couple? Are these couple?
Yes, sir.
Yeah, because both have the equal amount of force and they are acting in opposite direction. So this is a couple, right? And what is the line of action? This is the line of action, right? This is the line of action. These are the forces. So it will not move in this direction or not in this direction. It will rotate, right? It will rotate. It will have some rotational effect. So yeah, we will talk about this thing in the next class, right? You guys just to remember that this is what. This is how much distance? What is the distance between the two charges in a dipole that we have already learned? What was the distance? You guys have forgotten all the things, right? A was the distance, right? So this distance is 2a, this is theta, and this is the perpendicular distance between the line of action, right?
Yes, sir.
Okay, so we'll talk about this in the later. You guys please revise force on a charged particle and dipole. In the next class, please come with this division and then it will be able, you guys will be able to easily understand it, right? Okay, so I will stop here and next class I will talk about torque and flux. So I will complete that chapter and I will in the next set of classes, I will start the electric potential. So please, you guys start revising. Otherwise, it would be again. You guys have to repeat all those things again if you don't revise now. Okay, I will stop here and I will give the time to note it down. So these things I will give the time to note it down, and yeah, see you guys in the next class. But you guys have this class assessment. So whenever you guys leave, please